Thanks for the introduction. I'm, like you said, I'm Alex Band. I'm the product manager at the RIPE NCC, making sure that you get the services that you need from your friendly neighborhood regional internet registry. And what I'm here to talk to you about is resource certification, so doing BGP origin validation using RPKI. And this essentially revolves around the age-old question, I see a route announcement on the internet, a BGP route announcement, and am I supposed to be seeing this? Is this route announcement supposed to be out there? Or did somebody make a configuration error on their router and announces something that they shouldn't be announcing? Did YouTube really set up a data center in Pakistan? Or is Pakistan Telecom maybe accidentally announcing YouTube address space? So answering that question and being sure about the decisions that you make with your routing, that is essentially what resource certification is for. So we're going to be talking about really doing BGP origin validation in a reliable way. Because everything that we've been doing up to now, I think everybody's familiar with sort of the concept of root objects that you can register in, for example, the RIPE database, or a root object that you can register in one of the other IRRs, so Internet Routing Registries, such as the RADB, run by Marriott. And you can collect all of this information, all of these root objects. But the problem is that the RIPE database, it has authentication built in, so only the legitimate holder of the address space, if you can authenticate against the RIPE database, you can create a root object. But the problem is that that doesn't apply for all of the internet routing registries around the world. So if you collect the entire set of all root objects that are available, then you're still left with the question, yeah, but were these created by the legitimate holder of the address space or not? And how do I reliably base a routing decision on this? So the problem is, this route announcement really supposed to be out there? And the solution that we currently have with root objects, it just doesn't really offer you a watertight system. And what RPKI tries to do, what resource certification tries to do, is legitimize all of that and lock it down a little bit more so you have more certainty and you can make more reliable routing decisions. Now, you would think, but routing, what does the RIPE NCC have to do with that? Because you just hand out IP addresses, right? You're the regional internet registry. You don't have anything to do with routing. You're not the routing police. You don't tell me what to do on my Cisco. Actually, no. Actually, you're absolutely right. We are not the routing police, and in no way are we trying to do anything in relation to that. But we are the authority on who is the registered holder of an internet number resource in our region. So we hand out IPv4, IPv6, and AS numbers, and all of that information is kept in our registry. And we try to keep this information as accurate and as complete as possible. So the change that we've made now, or the implementation that we've made now, is that using this registry data, we know who you are, we have a relationship with you as LARs, as ISPs. We know who you are, we know who holds a block of IPv4. And we put that information on a digital certificate. And this is just the standard X509 certificate. So the RIPE NCC has essentially set itself up as a certificate authority, and we have a self-signed root certificate with all of the address space that was ever handed to us by the IANA. And from that root certificate, we can issue child certificates to all of you, listing the IP addresses that you hold. And this is all done according to IETF standards. So we're using RFC 5280 just as a standard X509 certificate. And for that, there are extensions for IP addresses and AS numbers, so RFC 3779. And then how you actually operate and use that, for routing is described in the Resource Public Key Infrastructure RFCs from 6481 to 6493. And we've been doing this for a little over 2 years now. So since the 1st of January 2011, our members were able to generate a certificate, request a digital certificate with their resource information on it. And all that the certificate does is state that these resources were truly issued by the RIPE NCC. Nothing else. So the resource certificate, it doesn't even list your organization name. Nothing. It's just a public key and a private key and a hash and your resources. And you have control over that certificate. You can use that certificate to make cryptographically verifiable statements. That is all. It's a free opt-in service, and it resides in our LAR portal. So you can just log into the LAR portal, request a certificate, and we link it to the registration. The validity of the certificate itself is 18 months, and we renew it automatically for as long as you are a member every 12 months. So the fact that it has a validity of 18 months and we renew it every 12 months is like a safety measure that we built in, to make absolutely sure that if something goes wrong, we have 6 months to fix it, because the validity of your old certificate will just continue. And it is just an enhancement to our registry, and it just offers validatable proof of holdership. I mean, what you have right now is the RIPE database, and it has a piece of text sitting in there, for example, an INET-num object describing, well, the IP addresses that you hold, and then there's an organization object that has your name and address, and that's really it. It is just a piece of text sitting in the database. But what this certificate offers is validatable proof of holdership. So you can make cryptographically verifiable statements. So using that certificate is what it's all about. Because as I said, it's essentially just an empty certificate with your resources on it. So if you request one and then you put it in your drawer, then it's not very useful. You actually have to use your certificate for a certain application in order for it to be useful. Just like requesting an IPv6 allocation is meaningless if you don't actually do anything with it. So yes, you have the numbers, yes, they are registered with your organization, but if you don't actually build any infrastructure that supports IPv6, you don't announce your IPv6 on your routers, then you might as well not have it. And it's the same with the certificate. If you request one and you don't do anything with it, it just sits there as being a bit of a useless thing. So what you can do with the certificate is make statements with regards to routing. So you can say, I authorize that my prefixes will be originated from this autonomous system. And only the legitimate holder of the address space can create such a statement. And because this system is operated by the regional internet registries, all 5 of them, you're absolutely sure that if you see such a statement, that statement was truly made by the LAR who holds the address space and not by some random person. And you can cryptographically validate that information. That is essentially what it is. So such a statement is called a root origin authorization, where you say, I authorize this autonomous system to originate these of my prefixes. That's a statement. And then it has one additional informational element which root objects don't have. So that is essentially the only difference with it, which is the maximum prefix length. So you, as the holder of the prefix, can say, I authorize this autonomous system to originate these prefixes, and it may be deaggregated up to this prefix. So you have control over the level of deaggregation that an AS can do. So you can say, it's okay, this AS may originate my /16, and they may deaggregate it into several /19s, but if they deaggregate it into /24s, then I don't allow it. So you have control over that. That is what a ROA does. So using your certificate, you can create a cryptographic object that says this AS number, this prefix, and this is the maximum length. So all of this doesn't directly affect BGP, of course. It doesn't directly affect BGP, it's merely a statement about BGP. You say something about BGP. So you have this entire data set now with these statements, and you have real-world BGP where announcements are actually done. So you can compare these two data sets, which announcements are being done, and which ROAs have been created. And then you end up with, well, 3 possible states. I have a BGP announcement, and if I compare it to the ROA dataset, then either it's valid, yes, for this BGP announcement, I found the ROA, and it is actually authorized by the holder of the address space. The second state is invalid, where the legitimate holder of the address space did create a ROA for that prefix, but they authorized a different AS number. And that is essentially what a hijack is, right? A hijack is a prefix being originated from an AS that is not supposed to be doing it. So if you create a ROA for all of your authorized legitimate autonomous systems, then a hijack will automatically be flagged as an invalid root announcement. Like, no, it hasn't been authorized by the holder of the address space. And the third state is unknown. So that is essentially most of the data right now. There are, what, 450,000 root announcements in the world, and not all of them, not by a long shot, are covered by a ROA. So you have a BGP announcement, you look in the ROA dataset, in the repository, and you go, no, no statement. I don't know. So it's unknown. So those are the 3 states that you have, and every operator is completely free to base whatever routing decision that they want on these 3 states. So all that a ROA is an additional positive statement about the BGP announcements that you authorize, flagging everything that is coming from an unauthorized autonomous system as a hijack, as an unknown, as an invalid. So no, that is not supposed to be out there. Now that's a lot of talking, and that's a lot of theory, and I think it'll be a lot clearer if I just show you. So, live demos. Live demos on a Friday afternoon. This is going to be fun. So I'm going to go to our test system. I'm going to log into it, and I'm going to show you how to set this up. And I'm going to show you in our sandbox system for the RIPE NCC address space. And this is the interface that you have within the LAR portal. And the first thing that you see here on the right is all of your certified resources. So all of the IP prefixes that are associated with your LAR, with your ISP, they will automatically show up on your resource certificate. So the only thing you have to do is request the certificate, and then everything that you are the holder of will show up on the certificate. The next thing that we do is show you the BGP root validity. And what we do here is that the RIPE NCC has root collectors all over the world. And they peer with many, many other networks. And every BGP update that they see, they fetch it and they send it to a central database. And that is our root collector database. And you can use it for analysis, and actually now we're using it ourselves to show you this. So these are all of the root announcements that our root collectors think you do with your address space. So this is what the root collectors think the announcements are that we do with our address space. So we show you We take all of the root collector data, we overlap it with your certified resources, and then we show you these are the root announcements that we think you do. And then the question is, we see this root announcement, do you authorize it? So the fact that 2001 67C 2E8/48 is being originated from AS 3333, is that supposed to happen? Is that supposed to be out there? If the answer is yes, then the only thing you have to do is place a check mark next to it and say, suggest me a ROA. And then it creates this cryptographic statement that says, yes, so for AS number 3333, for prefix 2001 67C 2E8/48, with a maximum length of /48, I have created a ROA. And now the root validity state will go from unknown. After we publish this, it will go to valid. So you can see in the user interface, before you even publish your object, what the result will be. So you will see that it will become valid after publication. So this is what I want. So I'm going to publish changes, and now this cryptographic object is published in a repository that is free for anyone to download and use this information. And that is all. So if I now go back to my dashboard, I can see that the root validity for this root announcement is now valid according to the RPKI dataset. So I can just say, yes, these are all valid, or I can just say select all and say suggest ROAs. And it will create all of the objects. The validity state for all of them will go to valid after publication, and I hit publish changes. So in the configuration interface, you don't have to deal with any of the cryptography. The certificate is there, it's a hosted system, and the only thing you have to do is worry about entering data. But you're like, wait a minute, this is like, all of the crypto, you're hiding that from, but where does the private and public key reside? Actually, yes, it resides on our servers. So when you request a certificate, you have control over the certificate, but the certificate itself in the hosted system resides on a hardware security module, so an encrypted box inside our data center. And you can use that certificate to issue these statements, but you would think as a security expert, you go like, wait, what? But I should be the holder of my private key, right? It should be me. It shouldn't be the RIPE NCC who operates that. Well, actually, yes. The system was designed for everyone to run their own certificate authority, and you can. So you can set up your own private and public key pair, set up your own certificate authority, be responsible for your own key rollovers, and you can talk to the RIPE NCC parent system and have all of your resources pushed onto your certificate. So that is how the system was designed. So you as a user have a choice. Either I'm going to be running my own certificate authority, or I'm going to be using the hosted system and I'm going to let the RIPE NCC take care of all of the key rollovers and all of the crypto and managing all of that. So you have a choice. The thing is that now in practice, the choice exists and people are free to do whatever they want, but practically there are now more than 1,000, there's actually 1,350 organizations that run RPKI, and there's more than 5/8 blocks worth of address space signed and covered by a ROA, and there are 3 LARs who run their own certificate authority because they felt that was a good idea. So while it is an option, in practice we're not really seeing it. But this is also because running your own certificate authority is not something really simple. You have to actually manage this and take care of this. And if you don't, then keys can expire, things can go wrong, you can go offline, and you know, and as there's not really a lot of value right now in the grand scheme of things, people are just trying it out. People are just getting some operational experience with this system, and they just want to see what it does. They just want to see what effect it has on BGP and how they could use this in their routing workflow. So to set up your own certificate authority just for that is, for a lot of people, a little bit too much work. So that is why we built the hosted system. It is essentially just for convenience. It's to take the work away from you, but if you would like to do it all yourself, then you can. If you would like to play with the hosted system, also an option. So have a look what you would like to do. And this is essentially one side of using RPKI. It's making the statements. It's authorizing the legitimate route announcements that you authorize to be out there. That's all you have to do. There's an alerting system built in that says you can configure it and you can say, I want to receive alerts about invalid announcements and unknown announcements. So suppose you get new address space, then these route announcements, they don't have a ROA yet for it. And you can get an email notification saying, oh, you need to create ROAs for this. Also, if something becomes invalid because, for example, you changed your BGP configuration, but you forgot to update your ROAs, the system will also send you an email and say, either somebody is hijacking you, or you forgot to update your ROAs. So it has active notifications of your configuration. It'll send you an email once a day if there is something that requires your attention. And that's really it. The only other thing I can say about this interface is that there may be something that you purposely say, yes, I want this to have the state unknown, or yes, I want this to have the state invalid. I know this is invalid and I intend to keep it that way. Please stop emailing me about it every day because it's getting kind of annoying. In order to do that, you can place a check mark in front of it and you can say suppress alerts. And then you won't receive any email notifications of that particular route announcement if the validity state changes. So you're not being annoyed with emails if you don't want them to. You can specifically select which ones. That's really it. That's really all you have to do in terms of entering data into the system. And as I said, there are now 1,350 LARs who have done this. So if you go to ripe.net, certification, and you go to resource certification statistics, you can see this is sort of the growth that we've been looking at over the last couple of years. A lot of people are enabling this system, and if you look at the total amount of IPv4 prefixes in ROAS, for example, it is now currently hovering around 3,200. Almost 3,200 prefixes that are signed and backed by a ROA. So the data set is really growing. It's really getting there, especially in this region. Yeah. And for something that has existed for 2 years, it sort of depends on how you look at it. Because on the one hand, you go like, you've got an awful long way to go. But if I personally, when we launched the system on the 1st of January 2011, I thought, well, this is going to be like IPv6 and DNSSEC, right? Where after a year, we're going to have 20 early adopters. So I never expected that we would actually have more than 1,000 and so many prefixes in the system. And this, on a global level, it sort of translates to 10,000 BGP announcements. So out of 430,000, it's really nothing. But if you look at the larger LARs, like Deutsche Telekom, France Telecom, they all have their ROAS published. It's actually, if you look at the RIPE NCC membership, it's the ocean of smaller members that haven't got it set up. But out of the larger members, it's actually quite a large adoption rate. So now you're like, okay, that's great. All of these statements are made. Now, how do I use them? How do I access this repository, and how do I use this in my routing workflow? Well, that's the next thing I would like to show you. Making routing decisions using the RPKI dataset. So all certificates and ROAs are published in a repository, and they're available for download. And then software that runs locally on your machine will fetch all of this information periodically, run cryptographic validation on it, and if it passes validation, then it stores it in a file. And it's essentially just a really simple comma-separated values file containing 3 things: AS number, prefix, maximum length. But the point is that you run the validation software yourself locally on your machine, because you don't want to rely on a third party to do the validation for you, because, well, if we do that, then we might as well just take all of the crypto out, right? And publish it as plain text, if you're going to be trusting a third party. So we encrypt it, and you're supposed to be, or we sign it, and you're supposed to validate it. That's how the system is designed. So the validated cache is essentially that comma-separated values file. And we have got a tool set built for this, where you can do this. And all that it requires is Java 1.6 or newer, and rsync available on your system. Those are the only 2 requirements. So you don't need any installation. You just run the program /bin/RPKI validator. And then a web interface where you can configure it and view the information will become available on port 8080. And this is what it looks like. So you see all of the different trust anchors from all of the different regional internet registries. They connect to the trust anchors and follow the entire tree of certificates down and all of the ROAs. It fetches them, it validates them, and it puts that information in the system where you can access it. But obviously, screenshots are boring, and we like live demos, right? So I downloaded that and unzipped the package to my desktop, and now I'm going to be doing this on my lowly MacBook Air. It's i7, 8 gigs of RAM. It's not really, it's pretty good, but it's just not exactly server-grade hardware. Let's see. Yeah, and what did I say? /bin RPKI validator? Please work. Yeah, so it's loading the trust anchors, and you get this interface. It's now it's fetching over rsync. It uses rsync because it just compares the differences between what you already have, what is available on the server, and it just downloads all of the differences. So that's why rsync is used as a protocol. And it validates that information. Also what it does is it collects all of that root collector information that I showed you in the LAR portal. The RPKI validator does that too. So you get sort of a BGP preview. So the validity state of your root announcements, or of everybody's root announcements, also become available within the interface. But looking at this command line stuff is, of course, not really interesting. With a bit of luck, I can go to localhost 8080. The first question it will ask is, do you want to send performance data back to the RIPE NCC? If you say yes, then metrics on how long it takes to validate, how long it takes to connect, that kind of thing is sent to the RIPE NCC, which helps us scaling the system. I'm going to say no for now. And here is a short overview of BGP origin validation as this validator does it. So it starts with the trust anchors, it downloads all of your data, performs cryptographic validation on it, and then you have a set of ROAs. But you may say, I don't care what the global system says about a certain set of IP addresses. I have my own local policy for it, and I don't wish to rely on the RPKI dataset for it. So this prefix set I would like to ignore. This is what you can do in the ignore filters. You can just say, whatever. I don't care what it says. I want to apply my own policy, so just ignore it. You can also say, even though in the global dataset there is no ROA for this AS number and prefix, but I think there should be. You can also create one locally. So you can add local whitelisting and local overrides. You're completely in control of this dataset. You don't have to rely on it fully. So we built in overrides for you where you can ignore things and you can whitelist things. You can just say, okay, this is how I would like to see the world. And then all of that information, you can either process it as a comma-separated values file in an existing RPSL workflow, but Cisco and Juniper have actually built support for this in their routers. And with that, I don't mean that the routers do the crypto, but they can talk to this validation service and fetch this comma-separated values file and use it within their own local configuration. So you can create route maps based on an RPKI validity state. I'll show that to you in a minute. So here are the trust anchors. Here are all of the ROAs. Here are all of the ignore filters. And I can, for example, say 193.000/19. That is the RIPE NCC address space. I would like to completely ignore that. And then the thing that the RPKI validator will do is it will show you here which prefix will then be ignored. So there was actually a ROA for 193.0.024/21 being originated from AS2121. So it used to be valid, but because you now ignore that entire range, it is treated as unknown. Like I'm going to pretend it doesn't exist. And essentially with the whitelist, it's the same thing. So you can say, this AS number, this prefix, this maximum length. So it is like creating a ROA, but then not in the global system, but just to your local configuration. And then here's the BGP preview, and that is again, root collector information, all of the announcements that we see. And I can, for example, in BGP preview, search for valid, and it'll show you all of the ones that are valid. Or I can say 193. I can enter a prefix, and I show you all of the announcements that fall within that prefix. Or I can enter an AS number. And I'll show you the results for that. Here's the export button, and I can just download this as a CSV. Now, there we go. This is it. So this is the global data set for RPKI. These are all of the AS numbers, all of the prefixes, and the maximum lengths. So you can just process this in whatever workflow that you like. And the power over this, it really looks like a root object, right? It's a combination of AS and prefix. But for all of this, you can be absolutely 100% sure that these statements were made by the legitimate holder of the address space. Absolutely sure. How you process this data, up to you. So the thing is that this is a static link. So you can just use a cron job and wget to get it, and then process it in your router configuration. But if you have an RPKI-capable router, you can set it up so it talks to this validation service and fetches it directly. Now, in order to show that to you, I'm going to connect to an RPKI validator running in the office, and you can see router sessions. Let me see, there is one. 193.047 is connected. So there is, in our office, a Cisco 7200 that has RPKI support, and it fetches this list from the RPKI validator periodically. Jan Zorsch, who is sitting over there, he just set that up on his Cisco 7600 running 15.2 at the coffee table. We just installed the validator, hooked it up, and let it talk to it. And essentially what you can do is just create a route map based on this information. So let me just go back to the slides and give you a little overview. RPKI support in routers, the communication that is done between the RPKI validator and the router itself is the RPKI RTR protocol, which currently a draft, almost a standard. There is production support in the ASR 1000, 7600, ASR 903, 901 in these releases. And Cisco also has an early field trial for all of the iOS XR platforms. So if you contact your local, friendly local Cisco representative, you can get one of these early field trial images. And play around with this. You just have to install the RPKI validator and set it up. Juniper has had production support since 12.2, and Quagga has support since BGP, in BGP SRX secure routing extensions. So this allows for the same configuration in a Quagga environment. These are the only manufacturers that have it set up. So no Brocade, no Alcatel-Lucent, no other vendors. They're sort of waiting to see whether this is going to fly. But Cisco and Juniper are fully on board and they have production support. And then what you can do in your Cisco, because it has that list of valid AS numbers, prefixes and maximum lengths, and it has that logic of what is then valid, what is invalid, and what is unknown. So you can just create a route map saying, match RPKI invalid, set local preference to 90. This is how we configured our testbed servers. You can say match RPKI not found somewhere in the middle at 100, and match RPKI valid, I give it a higher local pref. So you sort of see the natural order of how you would use these three validity states. You would prefer something that is valid over something that is unknown, and you would prefer something that is unknown over something that is explicitly invalid. You can also be really paranoid about it and say, if it's invalid, I drop it. Whether that is a really smart idea to do now, maybe not. Because at the end of the day, you can be sure that data was entered by the legitimate holder of the address space, but they may be creating ROAS that are not really smart. Because if you set the maximum length incorrectly, or if you authorize the wrong AS number, or if you authorize an entire aggregate from one AS number and you announce more specifics from another AS number, for example, from your customer, you need to be sure that you have ROAS created for them. Because if you don't, they will all show up as hijacks. They will all be invalid. So you may be dropping lots of things because somebody forgot to create some ROAS. So that is why we were so meticulous in creating this alerting feature and making people aware, like, you have invalid, either you're being hijacked or do something. But you still have enough people that ignore that. So data rot, data craft, sloppy data entry is something that you will see. There are quite a number of invalids according to the BGP dataset. I think about 1,500. I don't think right now there are 1,500 hijacks going on. These are just people who are very poor in entering data. You also have to take into account that all of the effort that we put into the user interface at the RIPE NCC system is not necessarily the case at the other RARs. So for example, in the LACNIC region, there's also a lot of invalids coming from there. And the only thing that will happen is they will be solved, but then the first person, the first large operator will have to say, I'm dropping you because it's invalid. And then that stuff will be fixed really fast, right? So my advice, if you do this, if you're going to set up ROAS, you have to be meticulous about it. And you have to maintain the data set. If you're just going to enter some ROAS and walk away, and you change your routing or you get new addresses, then you're better off not doing it at all. You have to maintain your data, because data rot is terrible for the system. We have some public test beds. So the RIPE NCC, that 7200 that we have, it's actually open to the public. You can just telnet to rpki-rtr.ripe.net with the username RIPE and leave the password blank. It doesn't have an enable password, so you can't actually change the configuration, but you can run lots of show commands and see what the configuration is like. And Eurotransit, actually now called Kaya Global Networks, just renamed, they have a public Juniper running 12.3. And you can telnet into 193.34.50.25 with the username RPKI and a password testbed. Now, this URL that you see at the bottom. Let's just go there, and I'll walk you through the configuration. First with Junos. First you set up communication with the RPKI validator service, so it gets, periodically, it gets all of the validated cache. Then you assign a policy, and that policy example that I gave you for Cisco, this is how you would essentially do the same thing for Juniper. So you say, if the validation state is valid, then set my local preference to 110. Then you configure your BGP neighbors and peers, and then you can start checking whether it's actually working. So show validation session detail, show validation statistics, and show validation database. And this list, origin AS, prefix, maximum length, that is essentially the comma-separated values file that I showed you coming out of the RPKI validator. That is what it is. And then you can see if your policy is applied properly. Show root protocol BGP validation state valid. It will output all of the BGP announcements that your router sees that are valid. And as I said, you can try this yourself in the testbed. And this is the one for Cisco iOS. So BGP RPKI server TCP, the IP address, the port, and the refresh time. Then you apply your configuration. So you set up your route maps. Then you check the connection with show IP BGP RPKI server. And again, here is that list. Here's that comma-separated values file that is imported automatically. So it is so simple to do. You run the validator, change your Cisco configuration, it imports the data, and you apply some route maps. So that is why Jan and me were capable of just doing it at the coffee table while standing here, because it's really simple to do. And it's an additional data point that you can use in making routing decisions. And then you can just run a show IP BGP for a certain prefix. This one is valid, and this one is, for example, invalid. It's as simple as that. All of this information, so what I just showed you and how to use this, is available on ripe.net/certification. So how to configure the routers, how to run your own certificate authority, all of the elements is available on that website. Everything is described in detail. Also, the LAR portal user interface, it has a product tour. So it guides you through all of the steps in the user interface, sort of helping you out. Also, on Twitter, there's a lot of tweets going on about RPKI. So if you follow the RPKI hashtag, it's actually quite a good way of keeping updated with the information. And then if you have any general questions about this, send an email to certification@ripe.net, or if there's something that you need from me, just send it directly to me at alexb@ripe.net, or follow me on Twitter. Any questions?
1 second.
Yeah, I mean, you put a helmet on.
Hello. I have a question, but it might be a little tough to explain.
Yeah, okay.
Let's say my current friend, but he has a prefix and he has his own origin. And we don't cooperate in any way. And I announce his prefix with his origin, ASNAM, as a first one, with my second ASN as a second one.
Yeah.
So this RPKI doesn't stop that. Because this prefix will be still valid. But I'm doing this illegally.
Let me put it this way. With regards to making ROAS, the only thing that is locked down is the address space. So you as an LAR, in the LAR portal, you can only create a ROA for prefixes that are yours. But the AS number is completely free. So you can authorize any AS to originate your prefixes. If you originate your prefixes from multiple ASs, you need to be absolutely sure that you create a ROA for both. Because if you don't, then the one that you didn't create a ROA for will be seen as invalid.
I'm afraid you.
Okay.
I didn't clearly ask what I want. Is there a way to validate prefixes that are being transited by a second AS autonomous system?
No, this is just about BGP. This is just about origin.
Because without this mechanism, the originator can create false AS path in prefix, so it originates with a valid AS num,
yeah.
But he doesn't even he isn't even close to the network.
Do you mean that anyone will be able to spoof the AS number?
Yes. False AS
so BGP origin validation, as it is designed now, only provides the origin validation, not path validation. So you can still spoof the AS number. But currently, this is a building block to create path validation, where essentially every step in the BGP path is signed and decrypted at the end. And currently, in the secure secure interdomain routing working group in the IETF, they are creating standards for path validation that can be built on top of this system.
I'm sorry, I have to apologize because I wanted to make people aware that they don't have to be 100% sure that this is a good originator.
Yeah.
Because this is a missing part here.
It's actually a good point. I should have pointed out that this doesn't prevent you from spoofing the AS number and making it look like a valid announcement.
And
that is
I
true.
have a second question. How far is implementation in other RIRs?
We are doing really, really well, but this is very typical for the RIPE region, that we are always ahead of the curve with any technology. If you look at the IPv6 adoption in the RIPE region compared to the rest of the world, we're also ahead of the pack. So the other RERs, all of them are actually quite far behind. Aaron is really catching up now, but they started a lot later. They only enabled the system like a couple of months ago.
Because this region still relies on paper-signed LOAs.
Yeah.
Okay, thank you.
You're welcome.
Thank you. And I'm afraid we don't have any more time for the questions.
That's fine.
So thank you very much for the presentation.
Thank you very much for having me.